Hello everyone, I am Melanie Derksen and I am going to present our work, SPLOCIS, extending SPLOMs to a scatterplot cube with interactable shadows for immersive analysis in VR. In data analysis, scatterplots are a common initial tool for exploring the relationship between two or three attributes. They make data trends visible by plotting data values of attributes in a Cartesian coordinate system. In this case, we see plots with the attributes A, B, and C. When dealing with multivariate data, scatterplot matrices, or SPLOMs, give an overview of multiple attribute combinations by showing numerous 2D scatterplots arranged in a matrix. Although past research could show that VR can enhance data analysis compared to traditional 2D desktop setups, identifying and retrieving the most relevant plots from a larger collection still remains an open challenge in real-life immersive data analysis scenarios. Therefore, this work approaches the question of how to make 3D scatterplots effectively, comfortably, and intuitively explorable in immersive virtual environments. Even though the aforementioned SPLOMs seem to be suitable for this case, their two-dimensional nature is optimized for conventional 2D desktop displays, and extending them directly to 3D most likely causes visual clutter. However, the third dimension and immersive nature of VR offer novel opportunities for extending the idea of SPLOMs to 3D. That is why we propose a novel immersive data exploration system called SPLOCIS, scatterplot cube with interactable shadows. Our concept is based on 3 SPLOMs positioned on the floor and 2 walls in the virtual scene. The SPLOMs form the interactable shadows and span the so-called scatterplot cube, which contains every 3D plot. To prevent visual clutter, all 3D plots are invisible per default. They can be turned visible by specifying certain sets of attributes per axis, which makes only those 3D plots visible that have those attributes on their respective axes. The specifications can be set by either selecting the labels located at the borders of the SPLOMs, and this way specifying one attribute per axis, or by selecting individual 2D plots in the SPLOMs directly, and this way specifying 2 attributes at once. This way, the user specifies step by step which attributes are of interest, filtering which 3D plots should remain visible for further investigation. If a 3D plot instance is dropped close and nearly parallel to walls, it casts projections on them, which are again 2D plots. To evaluate our system, we conducted a user study in which the participants had to solve typical scatterplot exploration tasks with the help of SPLOCIS. Users had to find 3D plots with 3 specific attributes, so for example A, B, C, plots with pairwise linear correlations, so where the data points follow a trend line, plots having 2 clusters, meaning that there are 2 separate point clouds, plots having an outlier, so where at least one data point does not follow the trend of the remaining data points, and plots with none of the aforementioned relationships, so a random point cloud. Here we see an exemplary task to find a plot having 2 clusters. The user first identifies the attribute which causes the clusters, then filters out the respective 3D plots, and then grabs the 3D plot which contains the clusters. In total, 33 participants attended our user study. The aim was to answer 3 research questions we will go through in the following. First, we evaluate how typical scatterplot tasks affect performance and cognitive load within our application. According to the NASA questionnaire, the mean task loads per task type are all notably lower than the averages reported in the literature, which are marked by the green dotted and yellow dash dotted lines. While finding plots having no relation was classified to be on average the easiest, finding plots having an outlier was classified to be the most challenging one with the highest standard deviation. On average, tasks could be solved in less than 43 seconds, and while finding plots according to their attributes could be solved quickest, again, the outlier tasks took on average longest to complete. The same pattern evolves for the correctness rate. While the attribute's task type has the highest correctness rate of 99% on average, the outlier task has with 87% the lowest and therefore seems to be most challenging across all our metrics. A possible explanation might be that most tasks required to look for patterns which were spread all across a plot. On the opposite, the outlier task required participants to investigate plots on a deeper point-based level. And the high amount of data points present in the virtual room might have made it difficult to spot one single outlying data point within one plot, even though the datasets used in the study had clear outliers. Moreover, as a data analysis system should not only be functional but also understandable and easy to use, we evaluate its intuitiveness and suitability. Regarding the user experience, we like to point out the excellent values for stimulation and novelty, implying that SPLOCIS is innovative and exciting to use. With a below-average rating, perspicuity has the lowest values among the user experience categories, suggesting that it needs some time to get familiar with the system. And indeed, we observed that especially participants new to VR sometimes struggled with memorizing button functionalities. According to related work, our mean system usability scale corresponds to the grade A- and to a good rating. These results give evidence that SPLOCIS has an overall satisfactory usability and is suitable for exploring multivariate data. One participant suggested to enable the access to a detailed user manual at any time, which would probably support learning the system's handling. Lastly, we pay attention to the so-called repeated access assignments. With these, we mean 2D or 3D plots with at least twice the same attribute. One SPLOM typically contains repeated access assignments on one of its diagonals. In some cases, or in some visualizations, they are omitted, as these plots contain redundancies and might be less information-rich than the plots apart from this diagonal. Here we asked participants to name reasons for visualizing them or reasons for excluding them from the SPLOCIS system. Some valued them for gathering an attribute's data distribution in isolation and for providing a complete picture of the data distribution. Some brought up the aid of orientation to keep visualizing them for the sake of completeness and consistency, and that empty spots resulting from their exclusion would be irritating. Interestingly, some participants were of the opposite opinion and considered their existence to be confusing, apparently more than the aforementioned empty spots. And some called them to be unnecessary, as the information within those plots can be obtained somewhere else instead. 7 participants suggested a toggle mechanism that allows to visualize those plots if needed and exclude them otherwise, which would probably satisfy both of these distinct opinions. So, conclusively, we introduced SPLOCIS, an immersive system based on SPLOMs designed for investigating multivariate data through 2D and 3D scatterplot exploration. We presented results of a user study showing that our system provides a novel, efficient, and intuitive way to solve typical scatterplot exploration tasks in higher dimensions. Future work should focus on integrating the suggestions of our participants as well as advanced interactions like brushing and linking, followed by an evaluation of an updated SPLOCIS version with domain experts, as our group of participants had different backgrounds and varying experience levels. Furthermore, it makes sense to perform comparison studies with different immersive techniques to find out the individual strengths and weaknesses of their respective systems. Thank you for your attention.